that in 2022 we got about 62 billion kilograms of e-waste. And this e-waste was gone by different routes. The first route, the green one, it's only 13.8 billion kilograms of e-waste is documented as formally collected and recycled, and in environmentally sound matter. So that means it goes to some facilities that recover it and recycle it in a right way according to best technologies. Another routes are not so preferable, and unfortunately we have 16 billion of kilograms of e-waste. It's estimation, of course, and this amount of waste is collected and recycled outside of formal system. In high and upper middle income countries, we've developed e-waste management infrastructure. So in countries where they have developed infrastructure for recycling e-waste, but somehow organizational schemes are not as good, and not all amount of e-waste goes to the proper recycling. And another 18 billion kilograms of e-waste is estimated to be handled in low and low middle income countries with no developed e-waste management infrastructure, and mostly by the informal sector. So people do it by themselves, and they use very simple technologies, and sometimes dealing with e-waste according to this technology is not good for their health. It can be really dangerous. And last 14 billion kilograms of e-waste is estimated to be disposed as a residual waste, and the majority of which is landfilled globally, so landfilled. At the same time, there's a good potential in recycling and recovering e-waste, because if we look on another picture on the right, I guess, on the right side of the slide, we can see that if we try to compose, it was the last, yeah, thank you. If we try to compost this amount of waste, we can estimate that around 31 billion of kilograms, it's metals. So we can actually recover them and use them again in other applications. About 17 billion kilograms of plastic and about 14 billion kilograms of other materials that can be also sometimes treated in the right way and sometimes in the wrong way. So let's go to the next slide. Here I can show you these routes in more detail. So the first route, the formal e-waste collection and recycling. This route is possible in around 81 countries of the world, which has legislation on e-waste. Can be, not necessarily is. Sometimes there is a legislation, but still it doesn't work. But at least it can work. So if we talk about this environmentally sound matter, what goes here? So there are some retailers that collect old equipment. There are some pick-up services that also collect old equipment from households and from commercial enterprises. And there are some municipal collection points where people can leave the old things and be sure that this waste will be treated correctly. So again, it's around 13.8 billion kilograms of e-waste. All this e-waste goes to specialized treatment facilities. And they prepare this waste for reuse first, so try to avoid e-waste, then dismantling of hazards and valuable fractions to separate treatment, and or material recovery. And then the remainder is usually shredded and then separated before going to sometimes energy, sometimes material recovery. And in this case, we have about 1 billion kilograms of metal lost because technologies are still under development. They are not perfect. So even in this route, we have some losses of metals. But it's only 1 billion of kilograms, so it's less than 10%. And around 6 billions of metals, they brought back into economy through recycling. So they can be sailed again and used again in a new production. So this is the best what we can do right now. The second route, please, next slide. The second route is disposing of e-waste in residual waste. This option calls a less than optimal. So it's more or less okay, but it's not optimal. So in this case, people collect residuals waste in bins. And this is about 14 billion kilograms of e-waste globally. And then it also goes to incinerator, and it also goes through almost the same process, but not as good as the first case because technologies are less efficient. Not as new, not as expensive, less efficient. So in this case, we have already around 7 billion kilograms. It means half of loss of metals and other materials that go to landfill. It's a kind of sad situation because landfilling e-waste is not good for nature. And other 80 million kilograms, they are viable for recovery of metals and goes to recycling and may be recycled and used in economy cycles as well. Let's look on the third route. Please, the next slide. Thank you. Here we see the route for e-waste collection and recycling outside the formal system. But still, there is an opportunity to have e-waste management. We've developed e-waste management. It just says that this organizational scheme is not optimal. So technologies, they are presenting, they are existing, but sometimes not used in the right way. So usually here we see individual waste dealers. They collect waste from households and enterprises. And sometimes we also see companies that are working in this area. They specialize on waste collection and recycling. And there's an estimation that this route takes about 16 billion kilogram of e-waste. And it's managed by individuals waste dealers or companies outside of formal system. Here, it's usually, this e-waste is usually treated in the simplest way. So dealers and companies, they rearrange, how to say it, they take it in the parts. And some parts with the higher economic value they use and they sell. Some parts with middle economic value they can probably sell abroad. To ship it to other countries, and some parts they just throw away. And in this way, we have plastic recycling, which is hazardous. It can be bad for health and nature. And the last route is less preferable. Here we see, can I have the next slide, please? E-waste collection, e-waste collection and recycling outside formal system again, with countries with no developed e-waste management. So here we see self-employed individuals who collect e-waste, and the amount of e-waste is estimated as 18 billion kilograms. And these people, they treat this e-waste in informal way. Usually they manually dismantling this e-waste and do, like we say, cherry picking. So they take only the most precious parts. And all of the rest goes to the landfill, to disposal, and sometimes to formal facilities as well, but in informal sector. So let me remind you why it is a big problem. You can say, okay, that's probably not really good for the health, but why it is such a big problem? We can say that the wrong recycling and wrong management of e-waste have a really dangerous impact on the health of people who are dealing with this. And it can be people who are involved in collection and recycling, and also there can be people who live near these places, like landfills, like treatment facilities. They even probably don't know what is happening in the near neighborhood, but they are also exposed to these dangerous risks for their health. Another picture that I saved from last year, from my last lecture, it's this, because you are from chemical department, and I think this picture, oh, I'm sorry, please. Yeah, here's the slide with risks for the health. And the next slide, please. Here you can see as a chemistry table, and you see how many different elements we have in e-waste, and some of them are more precious, some of them are less precious, and some of them even critical. It means that materials that are rare on the earth, and we still have some lack of these materials in modern production. And next slide, please. So this situation is quite difficult, and of course we need a lot to do in this way, and it depends on our governments to organize the right system of collecting and managing e-waste. It also depends on new technologies, and sometimes we just don't have enough money. I mean, we as a society in any country, we don't have enough money to improve e-waste infrastructure. There are all these kind of problems behind. But what we can do? On this slide, it's well, actually, it's my opinion, okay? I'm trying to do research in this direction, and this is what I want to share with you, and to tell about two ways that we can do. Neither we have some support from the government or not. The first one is responsible consumption. It's a big idea behind these simple two words. Because responsible consumption is a part of circular economy, and circular economy is aiming to reduce, first of all, to reduce all kinds of wastes. And responsible consumption is very important because sometimes it's not expensive for us, and we buy more and we buy more, and even sometimes we don't really need it. So responsible consumption, it's up to us. No one can force us to be responsible in our consumption, but also it's up to us. We can do it even if it's not not required from the government or from other official organization. And the second thing is also very important is developing statistic procedures, because right now not many countries collect statistics on e-waste. In European Union, they have already developed system for collecting statistics, but in other parts of the world, there is still underdeveloped system of statistics monitor, and in many countries we are not sure about the amount of e-waste, and we cannot really forecast what amount we will have in the future. And actually it is a problem. Why? First of all, then we try to organize a formal system for collecting e-waste. We need to make it economically reasonable. And it's very important that we have here an economy of scale. It means that many people will use this infrastructure. Let me give you one example. Like, let's see one picture. We have a big city with many people, and we have some collecting bins for e-waste. And because it's many people in the city, they fill these bins very, very quickly, and it will be economically reasonable to collect it, to recover, and to try to return some economic value back by selling recovered materials. And another picture, it's a remote village with, let's say, 1,000 of people, and they will collect the same amount of e-waste for probably 100 years. So, and it will be not economically reasonable to keep developed infrastructure there because no one uses it. We don't have so many people. So then we try to organize this system for e-waste management. We also need to think how we can do it better from the economical point of view, how we can do it economically reasonable. We need to know how much of e-waste we are going to collect today, tomorrow, in 10 years, in the future, and then we can plan this system and facilities better. That's why statistics is so important. And right now, not many countries have developed statistics, but we could probably try to start with organizing our own research in this field and try to do like a pilot to estimate the number of the amount of e-waste in our neighborhood. For this, I talk, but I have some other pictures also. Can we go to another slide? Yes, I will be back to this. And next one, please. Okay. So this is about statistics. It's already basically what I already said. If we know the number of appliances, of equipments in the household, and the average life cycle time for each type of equipment, we can predict the amount of e-waste. And knowing regional differences will make it easier for us to forecast infrastructure, to plan it better, and to know technologies needs. So I will leave this slide for you, the next one please, with my contacts. And if you would like to participate in survey, the aim of survey is to estimate the amount of e-waste that you are collecting at home. So if you would like to participate in this survey, you can either contact me by this contact that you can see on the slide, or you can just tell Mr. Krisma, where's our professor, Chris Pranema, just to say that you would like to receive this survey. And I hope it will be our first time to try to collaborate in this way and see what this survey will help us to understand. Well, basically, that's it what I wanted to tell tomorrow. I don't know, should I answer questions right now or afterwards? Later? Okay.
Oh, later, yes.
Okay, okay, so that's done.
Okay, thank you very much, Professor Svetlana Ratner. Please give applause, everyone. Next, we are pleased to invite to the stage Professor Konstantin Komanov to the lecture sessions 2. Give applause, everyone.
Hello, everybody. My name is Konstantin Gomanov. I'm associate professor from Department of Economical and Mathematical Modeling from RUDN University, Moscow. Thank you very much for your attention. I'm very glad to be here and give a small lecture about forecasting of development green hydrogen production technologies using component-based learning curves. This topic is continuing Professor Svetlana Ratner's topic in sustainable development, especially in sustainable development goal number 12, consumption, which connected with consumption. And the sustainable development is also connected with the production of energy. And today we'll speak about the hydrogen, the green hydrogen, because it might become one of the essential decarbonization tools in the context of sustainable development, especially in sectors where the potential of other decarbonization methods is limited from technical point of view. According to International Energy Agency, there are about 40 countries, USA, China, Germany, and others, which already have hydrogen strategies and roadmaps for developing hydrogen production. If we are talking about green hydrogen, we have to point it that the production goes through electrolysis and renewable energy sources, and nowadays the costs are quite high, and it might be lower through scaling and learning effects. Nowadays, the global context of hydrogen production is about 94 million tons produced 3 years ago, and it's expected that it will be 20% more in recent 25 years. So the problem statement of our research is that a forecast of future green hydrogen costs based on the learning curves approach. The hypothesis is based on scientific data that suggests that the basis for the future development of green energy will be hydrogen energy based on renewable energy sources. The high costs of green hydrogen driven by expensive electrolysis and renewable electricity. So, as we know, there are a lot of methods of producing hydrogen. You can see on this slide. And we will focus on several of them in the context of learning curves. So there are some figures of hydrogen production today. So the left one, could you please, next slide, yeah. There are left picture. The green line shows the energy production in exajoules. The blue shows the hydrogen production till 2050, according to Energy Agency. And we see that the hydrogen production will rise in million tons till 250. And there will be the reduction of the cost production in about 20 to 40%. So the next slide, please. The methodology that we use is the learning approach. It says that the cost decreases by constant percentage with each doubling of cumulative production. And we also use multi-component model. It analyzes individual components like electrolysis, renewable energy separately. So here, next slide, please. On this picture, you can see in this table, you can see the importance for net zero emissions of each technology. And you also can see the readiness level of this technology. So you see that the very high level is for the electrolysis technology. Next slide, please. Here you can see that the capital cost associated with electrolysis, which can be found in different literature. So, for example, scientific articles, reports, and energy reviews. In our research, we used levelized cost of electricity and focused on several ways of production, such as PEM, AE, solar, and wind ways of hydrogen production. So the learning curves, next slide please. The learning curves methodology is based on the fundamental laws of learning theory, that is the cumulative volume of production increases, the cost of production decreases, and in this study we used the component by component learning curve methodology that is based on the available data of production of hydrogen and cost of AE and PEM technologies and the production cost of wind and solar energy. So what results we got? Please, next slide. So the current methods is steam reforming, Gall classification, water electrolysis, alkaline electrolysis, proton exchange membrane, and solid electrolysis were analyzed through learning curves. Next slide, please. So now we analyzed more than 1,300 projects in operation with very big capacity, about 240 gigawatts. And what we understood, next slide please, that learning rates for renewable energy are about more than 14%, for wind energy about 8%, for electrolysis, alkaline and proton exchange membrane is about 4% learning rate. And on another slide, please, you can see the pictures, the figures that shows these learning rates in solar, wind generation, alkaline, and proton exchange. So if we use these learning rates, next slide please, this slide, yes. And for example, we use four-way scenarios with different share of renewable and solar energy. We can see that the cost projection it will be about, the cost projection will reduce from 1.3 to 4.5 US dollars per kilogram in recent years. The next slide, please. The points of discussion are that the current market states of electrolysis limits learning rates and need for increased demand simulation over research investments. In optimistic perspective, other studies suggest higher learning rates, for example, 11% for electrolysis. And if we discuss policy implications, the government support crucial for accelerating cost reductions. We also have the limitations and the plans for future research. Please, next slide. Next slide. So the future research includes the transportation, conversion, and infrastructure costs. Also continuous data updates for more accurate learning curve projections. And in conclusion, I'd like to say that cost competitive of green hydrogen not yet cost competitive by improving. There is significant cost reductions expected through scaling and technological improvements. So it's also necessary the government support, especially in investment in research and manufacturing technologies. And it's also important for sustainability because green hydrogen holds high potential for economic benefits and net zero goals. That's it. Thank you.
Thank you very much, Professor Konstantin Kalmanov, to deliver the topics about the green hydrogen energies. Okay, and then for the last lectures, it will be delivered from Professor Svetlana Belousova. Please give applause, everyone.
So good day, everybody. Let me introduce myself. My name is Svetlana Belousova. I'm the head of the Department of Economic and Mathematical Modeling. And so I will draw your attention to quite another topic. It's mainly about economics, not about mathematics, and to be sure, not about chemistry and physics. But I think it's also very important, this topic, because it deals with sustainable development, but from another point of view. So I will focus on inequality and digitalization, because digitalization is one of the mainstream of our modern economy and modern society, and we are becoming digital persons right now. But the problem of inequality is very important for well-being of society, and so I think that it is important to discuss this question even without focusing on economics, but mainly about focusing of the agenda. So, plan of my lecture, I will skip some slides. We will talk a bit about how to measure inequality and how to assess the impact of digitalization on inequality. So, please, next slide. There is, as you very well know, 17 goals to achieve sustainable development. And goal number 10 deals with inequality. And there are 7 special targets to achieve this goal in several steps. And the goal is to reduce inequality between countries and within a country. And to talk about inequality between countries, there are several approaches, but the most common approach is to compare output. GDP, we call it, yes? Yeah, thank you. And as for gross domestic product, so the product which is produced by country and its residents. So as we can see on the left, left to you graph, the global output was growing greatly during last more than 50 years. But what is important is, for our topic, is the share of global GDP and how the share, how global GDP can be composed. And we focus on several groups. First, back please. One slide back. Yes, this one, thank you. So, of course, the USA is one of the leaders of the global economy nowadays, and it was so for more than half of the century. And this red line shows how GDP of this country was growing. The green one is about, the orange one is about European Union countries. And the blue one is about China. So I think you see what is known already for everybody, that China became one of the main producers of the global economy, and its share in global economy is 19% nowadays. But the green field is about the rest of the countries. So including India, Indonesia, Malaysia, African countries, Russia, and all other countries. And the share in global GDP is not increasing, at least just a bit. So that is one measure of inequality between countries. And next slide, please. The other measure is the gap between GDP per capita. And here is, you can see that despite the fast-growing developing countries, the gap between wealth of these countries are still very high and was growing at least till the global financial crisis. And after the global financial crisis, it still continue to grow. The same we can say about the crisis caused by COVID epidemic. So the problem of a growing gap between the wealth of people between high-income countries and even middle-income countries is quite clear, I think, and is essential for world development. But if we focus on inequality within a country, next slide, please. We mainly talk about income distribution. And talking about income distribution, we have several measures of how to assess the inequality within a country. And mainly we focus on income distribution between different groups and have several measures, ratios, how to compare inequality within a country between different countries. And next slide, please. The most popular measure, maybe you know it, is Gini coefficient, Gini ratio, and the distribution of income between several groups. So there are several rankings or I should say anti-ranking of the level of inequality. And according to World Inequality Report 2022, the less equal country is South Africa. Indonesia is on the 43rd place, United States on the 31st, and Russia is on 121, which is looks quite good. But if we rank countries according to the proportion of national income, which goes to bottom 50% of population. But if we focus on the richest part of population, we should note that Russia is very on the top of this anti-ranking and overperform Indonesia and very close to South Africa, because there is a big share of national income which goes to the 1% richest people. So please, I'll skip several slides. If you have question, we can come to this topic. And yes, as for, no, data source, please, the previous one. And yeah, slide number 15, please. Yes, thank you. So there are several sources of data, and you should be careful when you deal with the data, because there are different methodology to collect these data and to prepare these data for analysis. And so on this slide you can see that data are different from different sources, and so to deal with them you should be careful and pay attention on task you want to achieve. Either you either you deal with pre-tax income, either you deal with disposal income, that is after tax, and so on. So please, next slide. And next one, please. If we look at the Gini index, so this index says about inequality within a country. So the lower the index, the less inequality, the higher the index, the inequality is higher. So we can see on the example of China, as well as on other examples of post-Soviet countries, that liberalization reforms skyrocketed inequality in these countries. Let's look at China. It was rather low in early 90s, and now it's rather high, but it's even higher than in India and in Indonesia. So next one, please. But when we speak about inequality, we're talking not about inequality of income, but also about inequality of opportunity. What is opportunity? It's circumstances which is conditional to which the results, the outcome of efforts are different. And so the theoretical approach to assess the outcome as a result of efforts is take into account the circumstances, the opportunities. And as we deal in economy, as we deal with statistical data, so we use statistical approach to assess effects, to assess impact of some processes, and also this approach can be used to assess the impact of efforts on income or wealth or other outcome, taking into account opportunities. And what opportunity what is opportunities and what is obstacles to achieve results? Mainly we talk about such opportunities, such circumstances, or such obstacles as gender, race, place of birth, education, access to education mainly, family income, and all other things which can be regarded as obstacles or favor to achieve different results by individual. And what about digitalization? Next slide, please. Yes, when we also think about digitalization, digitalization can impact outcome through additional opportunities, and but it needs some additional efforts. Because when we talk about opportunities, we mainly talk about infrastructure and accessibility and affordability of ICT, mainly internet. And when we talk about efforts, we're talking about digital competitiveness of users, digital skills of users. And I will go to empirical study, please. Slide number 24. Thank you. And share with you results of some empirical study we've made about the impact of digital literacy on socioeconomic indicators. So on outcomes of, let's say, efforts of individuals. And the case is based on Russian regions. Next slide, please. And I'll skip this and others. Yes, slide number 28, please. And next, please. And why Russia is a good case for such a study? Because we have more than 80 regions, and from one hand we have developed ICT infrastructure in average, rather educated population, and the very affordable internet. The previous slide was slide which compare internet accessibility and affordability between Russia and Indonesia. If you are interested, you can look at this point. And of course, we have not of course, but we have developed public services, and the accessibility to public service is supported by government. But on the other hand, we have large differences between regions in terms of economic development and in terms of digital skills of population. So please, next one. And the next one, please. Yes, this one. Thank you. So to assess the internet adoption by population, we use principal component analysis and combine two main data about internet use of population, how it is accessible and how it is affordable, and how it is used among population. And so we subdivided all these 80 regions into 4 groups. The most development group in terms of skills of population and internet adoption, group number 1, and less developed group number 4, so low internet adoption and low digital skills. Next, please. As for economic structure of these groups of regions, it is not a surprise that the first group is more developed in terms of service, and so the blue one is the share of groups DGP from primary sector. It means oil and gas, metal, and other primary sectors. The green one is the share of groups GDP from industry, and the, I don't know how to call this color, something like navy blue or something like this. It comes from service sector. So the first group with developed infrastructure and skilled population, the share of service sector is quite high. So next, please. We skip this table, details, and this slide help to understand that the first group is more advanced, not only in terms of develop service sector, but also in terms of participation of population in long life learning, because long life learning is also the main modern society. And it is very important to participate in these long life learning, because skills are not which you can achieve from university, is not forever. You need to develop yourself. And of course, digitalization and especially high level of digital skills help to participate in this long life learning. And I should say that the result is not dependent on age or on gender. So any age, any gender resulted the same. So digital skills is important, but these two factors are not important. Next one, please. And next one. And the last I want you to show is the curve, which is the result of modeling data on unemployment. And these data comes from Russian regions, I mean the results of the model, but were simulated. So we simulate data if there is 70% of population with advanced digital skills and just 30% of population with advanced digital skills. And you see how curves are different, especially when we are talking about regions with large GDP. So the reduction of unemployment is very clear, I think. So in conclusion, it is very important not only develop ICT infrastructure, but make this infrastructure affordable for people. And what is even maybe more important is to develop, to reduce digital literacy and develop digital skills so we can gain some profit, we can gain some benefits from digitalization. So thank you for your attention, and I would like to answer questions.
Thank you very much, Professor Svetlana Belosova, for the lectures about inequality. The next agenda will be the question and answer sessions. So please, everyone, if you would like to ask to our guest speakers, please raise your hand. Okay. Please introduce yourself, your name and your major.
Check. First, let me introduce myself. My name is Fadil Nursami. I'm from the environmental science. So, excuse me, I'm sorry for my English. So this question is for Mr. Gomanov. Okay, so, sir, this technology, the green hydrogen technology, yes, was applied in many countries, right? And it's really difficult to apply it in this country, in Indonesia, because I think it's really too expensive for us. And what should we do so we can apply the green hydrogen technology? And is it worth it for us to spend the cost that's really high to apply the green hydrogen technology? That's it, sir.
Yeah, okay, thank you for your question. You asked very good question, but yes, but I don't have very good answer. So you see, the problem that we discussed is about the scale. So we need improve our technologies. We should scale our technologies, and depends on scale. Depends on scale will reduce the cost of production of hydrogen, especially green hydrogen. When we says it is produced through renewable energy sources. That's it. So we should improve technologies to make it a little bit cheaper.
Okay, sir, so you say that it depends on the skill, right?
The scale depends on scale. Yes.
So we need to start it with small things, then it's grow up to a big thing, or just improve the technology.
Okay, we should produce more hydrogen, do more things with hydrogen, so it will be economic effect measured in the scale, right? Like economic scale. So it offers you to make the production cheaper.
Okay. And the second question wasn't
Yeah.
answered. Check. Is it worth it to us to spend the high cost to apply this technology?
Yes, because everybody is speaking about sustainable development, and we should reduce the level of fuels in our economy. That's why we should make diversity of different kinds of energy sources. It is one of the way to sustainable development, especially because the energy system is one of the bases of sustainable development. That's why we need to make different energy sources more eco-friendly to our environment. That's why the hydrogen is one of the ways.
Okay, thank you, sir.
Yeah, welcome.
Is there any questions? Okay.
Okay, let me introduce myself. My name is Fadil Ardelia, and I'm from Environmental Science undergraduate student in UNS. I would like to ask to Mr. Konstantin Komenov about how does the cost of electrolyzer impact the overall cost of green hydrogen production?
The
Thank
cost of
you.
electrolysis, how the cost of electrolysis
Impact the overall cost of green hydrogen?
Yes, so in our study we analyzed different sources, especially used the electrolysis. So we showed how in the future it will reduce the price for hydrogen production. So the reduction will be about it depends of the energy sources, but it will be sometimes 14%, sometimes 8% per each step. So you see, we can expect that the reduction in total price will be from 1.3 to 4.4 dollars per kilograms of hydrogen.
Thank you.
Is there still any questions to our guest speakers? Okay.
Thank you. I'm sorry, maybe my question for Mr. Konstantin too, because my specialization in polymer electrode membrane, currently research in lithium battery and fuel cell application.
Nice to meet you.
In the hydrogen production, you already present about the electrolysis with in the electrolyte. I'm sorry, in the alkaline water, and then using polymer electrode membrane, right?
Yeah.
Yeah. We know that when we electrolyze water, the mechanism will produce oxygen and hydrogen. And sometimes we will focus in the catalyst. It's very expensive, and then the polymer electrode membrane have the high cost too. Maybe you can give a suggestion from your analysis, from your curve, maybe from mathematics or economically, which one we should focus in this application. We should focus in the catalyst or in the polymer electrode membranes, because to kind of this material is should be, maybe we give higher extensive in the funding.
Okay,
Thank
I
you.
understand your question. Thank you. You see, in our research, we didn't focus on these things as you said, because we're economists. We are not. We not do natural science. But it's very good question in the way that we should focus on it in our future research as a part of the model of learning curves or something like this. So if we are going to analyze the price of hydrogen production, we should use all the main or all the most influenced components of such technology as hydrogen production. So you see, in our research, we didn't focus on it, but thank you for that you paid attention on it. So we'll do it. We'll try to do it.
Is there any other questions? Okay.
Yes, thank you for the time. My name is Rian Davantoro, and my background, I'm a student in urban planner, magister urban planning. I wanna ask about circular business model to reuse waste problem. To Miss Svelana Ratner, maybe circular economy melibatkan apa ya? Have many actor, like government and private company, and then people. Maybe you have a recommendation to government policy to successful to become a successful circular business model. Thank you.
Okay, thank you very much for your question. It's very important and interesting, because circular business models, sometimes they are surprising. Like to create really interesting and reliable circular model, we really need to think differently. And I am not really competent enough to give some advices to your government. I guess it's your job to give advices to your government. But I can just tell you about some good examples how circular business model can be involved in waste management. Actually, I even had them on the slide, but I missed them because of the time. Well, the first example that I learned just recently from Portugal, Porto. It's a city. There are many IT companies with many IT startups, and they created mobile app, like a small marketplace for people who want to sell their used phones or computers or something, laptops, and people who want to buy. And it helps to circularize the flow of this equipment. And for some people, they don't need the best or the newest equipment. They are okay with, like, let's say, iPhone 7, not 16, or maybe they can use smaller and not so powerful computer, and it will be okay for them. So it's just an example how people can interact with each other, even without a government. I mean, it can be like peer to peer. And honestly, I think this is the best way to do it. Then people can organize the circular business model in a such way that we don't really need a government. We can do it by ourselves. Another example how to manage e-waste in a very smart way. It was example of, I don't remember right now for sure, but it's actually Microsoft server, Linux server example where people with not powerful computer can connect to a server and solve the problems even on this old equipment, and this allows them to not to buy new one. So there are good examples in the practice, and they are interesting, and maybe you also have good examples on this. And I think this is really the way how to do that, to create more models, to try how it works, and finally we will find a solution.
Thank you very much. Is there any other questions? If there is no questions, I would like to ask. Okay, because there were so many questions to Professor Komanov, so I would like to ask Professor Ratner and Professor Balasova. To Professor Ratner, that was very thoughtful presentations. As Professor Ratner explained before, so there are some actions that could be done to overcome e-waste, like by recycling, reuse, and preventions. I would like to know how the roles of Russia government to set the regulations or in real actions to try manage the e-waste problems. And the second question to Professor Balasova. My question is, you were saying before about the inequality. So I think it's about also the digitalizations that you said before. And as we know, like, the digitalization is not only giving the good influence, but also the bad influence like the cyber, not security, or is there any like a problem in cyber? So how we filter ourselves to know the or to do the digitalizations in a good way or preventions in a bad way? Thank you.
Such a big questions. I need another lecture to answer this question. But to make the long story short, I would say that in Russia, as in other many countries, right now we have a legislation which is called extended producer responsibility. It's a very powerful thing, but actually it works the best with packaging. Not with e-waste, but with packaging. But in Russia, there was an idea to test this legislation and to test this model on packaging, and then to include more and more different types of products into this law. And right now, it's still on the very early stage of development. So I hope maybe in a few years we will get some new results, but right now it's more about people. Like many people in Russia, they are quite responsible and they will never put like expired batteries in a trash bin because we know it's too bad for environment, and we will search for our neighborhood to find a place where we can leave them, and actually we can do that. So it's more about people right now, not government is somewhere doing something, sometimes not really a good connection with society.
Thank you for your question. It's also another lecture. Yes, but I'll try to be short as well. And as for digitalization, so we really become digital person and supervised by someone who is dealing with these applications and so on. And sometimes we feel like we are in digital prison. Yes, that's right. And the way to escape it is to maybe put this digitalization under the control of the society. This is the first way to deal with it, with this problem. And the other is, again, to reduce, to increase digital literacy, to increase the ability of people to understand the risk and to understand the consequences of their being on internet, on their using some applications and so on. So again, be educated in this field. Thank you.
Thank you very much, Professor Rotner and Professor Balasova and Professor Komanovs. So before we come to the closing, would you, one of you, maybe explain the opportunities to our students about the exchange program or study abroad to RUDN University, or any some scholarships that we could apply?
Thank you for this question. And I really like to welcome students from Indonesia and from university in Moscow, in RUDN University. Maybe you know already that our university is one of the most international universities, not only in Russia, because we have students from more than 160 countries now, and from Indonesia as well. So tomorrow we have an Olympiada for those who want to be a master student at RUDN. Oh, bachelor also, yes, sorry. But for you, maybe it's not very important about bachelor studies, but master studies, yes. And we have 17 faculties, and the Faculty of Natural Science and Mathematics, the Faculty of Economics, the Social Science, Medicine, Agriculture, and so on and so forth. So one way is to participate in Olympiada and to win. Then you will waive out of tuition fee. The other way is to apply for the government program that is for bachelor and for master studies and for PhD studies as well, to apply for government programs through the government, to apply for our Russian representative in Indonesia, and there is a way to have government support and again a waive of tuition fee. So the third way is just to apply and pay for education. Yeah, it's not very high, but it depends on what you'd like. But you are very welcome to spend some time during summer schools, because we have some summer schools at RUDN. And I think we'll give information to our organizers about these summer schools. And what was other questions?
Scholarships?
Scholarship. Yes, scholarship. We have scholarship for master studies of our students from bachelor, graduate from bachelor studies. But as for foreign students, it's through government program.
Thank you, Professor Balasova, for the explanations. Please give applause, everyone, to our agenda today. We have now reached the end of our events. Thank you for your attention to all the audience. Once again, thank you very much for Professor Svetlana Rochner, Professor Svetlana Balasova, and Professor Konstantin Gawanov to give the guest lectures to us today. And for the closing, we will have the photo sessions. Please, all of the audience to come to the stage because we will have the photo sessions together to all of you.
Thank you very much for everybody.
Thank you. Kepada para audiens sekalian bisa maju ke depan karena kita akan melaksanakan foto bersama. Mas, boleh dihitungin ya, Mas? Thank you very much, everyone. See you on the next guest lectures.